there! How do you like that? I know, I'm not good at playing the Theremin yet, but I just wanted to show you that I finally made it. Version 2 is now complete, and in this video I will show you how that happened. Enjoy the view! In the last episode we discovered that we could overcome the issue with the coax cable capacity by shorting its center wire with the surrounding shielding, which makes the coax cable behave like a normal wire. After a better exam of this solution and after trying other options, I ended up realizing that the removal of the coax cable was the best way to solve the problem encountered with the coax cable. Any other option of keeping the coax cable ended up in a failure, because the high capacity of the cable was making negligible the capacity changes of the antenna while moving a hand in front of it. In short, the only way to have a reasonable range of frequencies to play the theremin is to not use a coax cable to connect the pitch antenna to the pitch variable oscillator. Once that was settled, I decided to move on and start making the final adjustments to the tuning of the theremin. In particular, the one thing that was left was the tuning of the pitch reference oscillator to a frequency that could give the maximum excursion of audio frequencies with the best adjustment range of the pitch potentiometer. To do that, I had to take measurements of the whole range of both the pitch reference oscillator and the pitch variable oscillator, and then determine the best frequency of the pitch reference oscillator to use. Let's see how I did it. Let's start by working on the pitch reference oscillator. I'm gonna put my oscilloscope probe connecting the ground over here and the probe to the connector where we can read the output of the pitch reference oscillator. And here is what we can see right now. So right now we are having a frequency of 276 kHz. But what we want really to know is the range of possible frequency that the pitch reference oscillator can be adjusted. So let me start showing you which one is the control that allows us to do that. This potentiometer here is the one that allows us to change the tuning of the pitch reference oscillator. And we can turn it on one side to the other and so have a full range of frequencies for the oscillator. Let me put it all on one side where we can see the minimum frequency, and let's read this frequency on the oscilloscope. And the frequency is 272.6 kHz. I'm going to write down this information so we can use later on. So this is the minimum frequency, and we said is 272.5 kHz. I'm gonna now move the trim pot so that to read the maximum frequency. I'm gonna just show you the oscilloscope output here so you can see what's going on while I move the trim pot. And basically I'm just moving the trim pot all the way to the other end, increasing the frequency. So you can now see the frequency is 325.6 kHz, which I'm gonna write down also on my piece of paper for later use. So this is 325.6 kHz. So basically we have a range through which we can work of about 43 kHz, which I'm gonna write down over here. Let's now measure the same thing on the pitch variable oscillator. So I need to move the probe of the oscilloscope from this position to this other one over here. And now I'm gonna have to adjust the potentiometer or the pitch control exactly to its center, because that is where we want it to be when we start adjusting the pitch one direction or the other. This is a potentiometer. This is a 10-turn potentiometer, so I'm gonna make 5 turns to put it in the center. So 1, 2, 3, 4 and 5. I don't care about this one right now, but this is the one that I need. And now let's go back and take the measurement with the oscilloscope. For this one, I will take measurements without my hand in the proximity of the antenna, and another one with my hand in proximity of the antenna. And basically the one without the hand will be the highest frequency, and the one with my hand close will be the lowest frequency. And I will take a note of those two. So right now my hand is far away, and we are reading 275.1 kHz. So we can write them down. So the minimum frequency will be 275 kHz. I'm sorry, this is the highest frequency, 275 kHz. We need to fix this one. So now I'm gonna go back over there, and I'm gonna put my hand very close to the antenna to see what's the minimum possible frequency. And then we can read it together. You can see now it's 273 kHz. 272.9. Okay, my hand cannot stay very still, so I keep moving it. Let's try again and try to get it as still as possible. Okay, let's go with 273 kHz of minimum frequency. Okay, this is at 273 kHz. So we have a variation in frequency of about 2 kHz. Is this enough for our purposes? Well, let's think about this a little bit. Let's consider the center of the whole band of audio frequencies that we want to play, which will be A4, which is at 220 Hz. And then we have A5, A6 on this side, and this other side we will have A4, A3, A2, A1. That's the minimum possible frequency that we can have. So each of these is 1 octave, so which means that if this is 440, that's the center, A, this one will be 220 Hz, this will be 110 Hz, and this will be 55 Hz. On the other end, on the opposite side, A5 will be 880 Hz, and A6 will be 1760 Hz. So this means that for a range of 1, 2, 3, 4 and 5 octaves, we need a variation in frequency of 1760 minus 55, which is about 1700 Hz. We have actually the possibility of moving the frequency thanks to the antenna of about 2 kHz, which means that our theremin will be able to have a range of 5 octaves to play with, which is perfect. But this means also another thing. We have to set the pitch reference oscillator to a value that is just above the pitch variable oscillator, and for which the difference between the reference oscillator and the variable oscillator is about 55 Hz at the maximum frequency of the pitch variable oscillator. And so we have to have our pitch reference oscillator frequency set to the maximum frequency of the pitch variable oscillator, which is 275 kHz, plus 55 Hz, which is basically still 275 kHz. So if we set the pitch reference oscillator to 275 kHz, we will always be able to adjust the pitch variable oscillator to work in all this range of frequencies, because with the hand far away from the antenna, we will have a frequency almost identical to the one of the pitch reference oscillator, and thus the 55 Hz. And when we instead put the hand closer to the antenna, the frequency will start going down, and therefore the difference between the pitch reference oscillator and the pitch variable oscillator will increase, and we will go through the whole set of frequencies for these 5 octaves. And probably a little more, since the range of frequency is actually 2 kHz. So, to make everything work correctly, we now need to tune the pitch reference oscillator to a frequency of 275 kHz. So let's move the probe back to the pitch reference oscillator output, and let's tune the pitch reference oscillator so that it will emit a frequency of 275 kHz. So while I move the trim pot, I will show you what happens on the oscilloscope. And you can read the changes in frequency right here on the lower right corner. So let me start moving this. So we have to go down to 275 kHz. I will have to do that slowly so the reading will be correct on the oscilloscope. 278 right now, 77, 276, almost there. You need to be very careful now not to be too far away from the 275 kHz. Okay, I think that should be good enough. So that's it for the tuning, and now we can give it a try and see how the Theremin performs with this configuration. Okay, I moved in this other room so there is more space for you to see exactly what I am doing. This is the Theremin that I just finished building and tuning. And you can see the two antennas on these two sides, the volume antenna and the pitch antenna. Now I'm turning the instrument on, and let me do some regulations here to make sure that we can actually play the instrument in this room. So this is fine. The top shielding will be done with a sheet that covers the entire circuitry of the Theremin. The sheet needs to be insulated on the side of the PCBs, so to avoid touching the wrong thing and cause short circuits. But of course, it needs also to be a good conductor connected to ground on the other side to properly act as a real shield. To easily make this shield, I decided to use a cardboard that I can easily cut to shape and I can cover on the external side with a layer of copper tape. Before cutting the cardboard to shape, I had to do some cable management to avoid having wires going all over the places. I did that by bundling together the wires close to each other and distribute them along the most convenient edges of the support plates and side shields, trying to leave enough space all around to fit in place the top shield. And here is the cardboard, shaped to especially cover the volume control unit and the audio unit, which are the two PCBs that have high-frequency oscillators on them. Once the cardboard was shaped, I covered the external side with copper tape, like this, and then I positioned it inside the Theremin and electrically connected it to the rest of the shielding already in there, using some more copper tape. And now the final test. And this concludes the work of making the Theremin version 2. The Theremin is now complete and usable, and you have just seen what it can do. However, I'm still not satisfied about the quality of the sound, and so although the Theremin V.2 project is now completed, I am already giving some thought on possible refinements, especially in the area of the audio generator. And so don't be surprised if in the near future you will see new episodes on the Theremin, maybe just a version 2.1 or who knows, maybe a version 3.0. Stay tuned, enjoy playing your new musical instruments, and happy experiments!